Okay, so yeah, this is a talk with a clunky title. Build files are not generators are not satisfactory. Um, about a area which I find a little clunky in our ecosystem, and so this talk is kind of a op-ed sort of talk where I talk about my experience and how this has caused me to have some philosophical thoughts. And but first, let me briefly introduce myself. So I've worked with Bazel for several years now, working with integrating it with large code bases. I've written several Bazel rule sets, and I've also worked a lot on the tools which surround a build system, like continuous integration and deployment, and basically all the things that come together to make a good, strong developer experience. So unsurprisingly, because I have this experience with Bazel, I'm going to be talking mainly about Bazel in my examples, but I think a lot of what I say applies to Blaze and all of its family tree descendants. So here is a simple Bazel build file, which has a C++ binary and a C++ library. The binary is depending on the library. So in the Bazel build file, we have to specify things by targets, the binary target and the library target, and they both have source files. And the part we're particularly interested in here is the dependencies here in the depth attribute. And the fact that you specify dependencies in build files is kind of a cornerstone of Bazel's correctness and performance guarantees, because the fact that the build system knows up front what the dependencies of a particular compilation action are allow it to know that have correct incremental builds and also do a lot of the fancy performance enhancing optimizations that we've come to expect, like remote execution and remote caching. And because these dependency declarations are such an important part of the correctness guarantees of this build system, Bazel goes to a really great lengths to make sure that we're actually specifying these things correctly. So for example, if I just omitted the dependency, the depth attribute on the CC binary, Bazel would actually tell me that I did something wrong because it puts the compilation of the binary source file into a sandbox, which only includes the dependencies that I specified in the build file. And when I try to include the dependency header file, I just won't be in the sandbox and the compilation will fail. And for some languages, the protection is even more elaborate and sort of has multiple layers. So even if I disable the sandbox in Bazel, the compilation will actually succeed because everything on disk will be accessible outside the sandbox. But Bazel will still ask the compiler to tell it all the files that it included, and it will fail to build if any files were included by the compiler that I did not specify in depth. I think one of the more interesting error messages in this vein, though, is the one that you can get when you're compiling Java. So if you fail to include a direct Java dependency in a Java library rule, Bazel can detect that, and then it will explicitly tell you in the error message that you need to add a particular label to the target that you're compiling, and it will include this copy-paste command for bulldozer to actually mutate the build file to add the dependency that you're missing to fix the build and allow compilation to proceed the next time you run Bazel. So I find this very interesting because it makes me wonder if Bazel knows exactly what should be going on in order to fix a build and is giving you an automated command to run to fix it. Why does I, as a human, even need to be involved in this? So this is a insight which a lot of people have had about dependencies. They're declared in the source files already when we're writing them, so why do we have to also do the work of putting them into the build files? And kind of a classic solution to this now is the build file generator, which parses the source files, figures out what the dependencies are, and spits them into the build file. And I think almost any organization which is using a Bazel-like build system at any scale has invented this themselves or is using a pre-existing build file generator. So a really popular one for Bazel is Gazelle, which was originally for Go and paired with the Bazel rules Go, but now has plugin support for many kinds of languages. I also worked on a build file generator for several years and talked about the experience of that at BazelCon 2018. So you can go look at that talk if you would like to learn more about how build file generators work. So oftentimes the way this ends up working for the end user is that they have to run the build file generator before they can actually invoke the real build system. So I often, if I'm editing code in a particular Bazel package, I often write some sort of shell command like this, where I run the build file generator, and then if that works, then I run Bazel test over all the tests in that directory, and those two things kind of like provide a good feedback loop for doing software engineering there. And so this is a good thing to just keep running over and over in your terminal, and it's pretty convenient because it keeps the fact that you might have to update build system metadata kind of out of your way, and you can focus on editing the code. So that definitely feels like a developer workflow improvement. But I feel like build file generators are not all perfect and good, and the fact that they are kind of bolted onto the main build system like Bazel leads to a bunch of awkwardness. For example, sometimes you need to configure what the build file generator is doing to make it look in particular places for dependencies or ignore some dependencies for whatever reason. And there's several ways that build file generators have developed to do that, like having a template build file that the build file generator reads and gets some information from before generating the actual build file, or special comments which you put in the build file, which are ignored by Bazel because they're starlight comments, but are magically interpreted by the build file generator. And there's also a problem with like collaborative software engineering where maybe someone makes a change to the code that would prompt the build file generator to make a change, but they don't run the build file generator, and so then there's kind of this latent change sitting around in the repository, which someone else may run the build file generator and cause a change in the build file, which they weren't necessarily responsible for, and maybe that breaks the build, and then you have to like backtrace into what caused that, and so that is kind of a annoying organizational problem. And then the final one I've observed is the problem of scope creep. One thing that's interesting is that many people figure out that running the build file generator very frequently is a useful thing to do and are running commands like this. And people who write the build file generator realize that this is a piece of code that many engineers are executing a lot. And so it's a very powerful place to put other pieces of functionality which seem like a great thing to have. It's very easy for build file generators to, as imperative programs, to sort of expand its scope and get all sorts of other features like generating files that aren't build files and like doing various kinds of validation. And that's just because they're a really convenient place to put that sort of stuff, even though it's kind of getting outside of the scope of updating build metadata. All right. So, and I guess my largest philosophical unhappiness with the situation is that a build system like Bazel, its slogan is fast and correct, choose to. But there's a little bit of a rhetorical sleight of hand going on, which is that it's fast and correct as long as you have correct code with build metadata that coheres with the code, right? So from a perspective of an engineer, if I edit a piece of code and add a dependency, the code is correct and should compile from my perspective, but it's not correct to Bazel. And so the build file generator is kind of a way to plug the hole between my expectations as just a guy who hacks on code and adds dependencies and the build system, which needs the dependencies kind of extracted out of the source code and put into its own format. And I think it would be very powerful if we could marry the obsession with performance and correctness that a system a system like Bazel has with the convenience of the build system or of the build file generator. Now, that said, I think it's a very difficult thing to do that, and there's several reasons for that. One is just performance and scalability on large code bases. So a important aspect of the current system is that you can load the build graph and do things to it, traverse it, simply by looking at build files. You don't have to look at any source files, and since the number of source files is usually much larger than the number of build files, 10x is probably very much a conservative underestimate. That is a very important performance architecture for build systems. And so if we were actually going to extract dependencies from source files by parsing them, it would have to have very aggressive caching and parallelism to make that possible. And when you think about things that people like to do with a build graph, like compute the reverse dependencies for change files to run CI on only change tests or something, it sort of means that you have to have the dependency information for every single file in your entire repository up to date, which is a new challenge. And then there's also I guess what I would call usability and UX concerns to this. In some cases, just extracting dependencies from source files is actually not easy, and it varies a lot for particular languages. For example, Go is pretty easy, but in other languages, you may find yourself having to evaluate Turing complete macros in order to figure out what the actual dependencies of the code are. And then there's a whole slew of tweaks which people probably want to do to dependency extraction. There's platform-specific dependencies and optional dependencies. And then dependencies on generated code. So there's not actually a source file that dependency analysis would find, but instead something like a protobuf and know that generated a particular piece of code that could be included somewhere. So I would love to tell you how to solve all these problems, but unfortunately the solutions do not fit in the margins of this lightning talk, so I'm going to have to simply demur. But I did notice that at this conference, there's a lot of people who have been thinking about this too. So I really enjoyed Stu's talk about Pants V2, where it seems like they have really thought about and addressed a lot of the challenges that come from putting dependency inference into the build system proper. And also the next lightning talk immediately after me by Neil is apparently about a build system that does its dependency inference by tracing acts and execution. So I look forward to hearing that one too, and definitely thinking hard about this problem, and it's something I will be really wanting to think about when I get the chance to build a new build system someday. With that, thank you very much for listening, and I look forward to your questions and feedback.
In general, there is no note to incrementality other than it's not going to work until it doesn't, until it works. And the idea that Bazel is making decisions on your development of development, and the fact that it's only as correct as that system is the thing that highlights to me. Any build system that can't deal with the fact that you've got an incomplete definition or an incomplete specification for something is always the build system that drives me nuts. Still waiting for questions to come in the chat. If anybody's got anything, please post it. I don't know if it's significantly delayed for me, but an incomplete definition or an incomplete specification for something. Awesome. Well, I think we can move on to our next lightning talk. Thank you very much, Ben. I appreciate you coming up at the last minute for a great lightning talk. Next up is going to be Neil Mitchell, who is going to present Rattler, which is a simpler build, or rather a simpler builds for smaller use cases.
Apparently there's a question now.
Oh, good. How are you? What killer features would you take from various build systems if you were to build a new one?
Well, I guess I like to fantasize about things that are not even necessarily in any build system that I'm aware of. Anyway, I mean, I definitely feel like reducing boilerplate and as Stu talked about, and like this dependency stuff that so as the subject of talk is like kind of like the next big thing that will like change how we think about build systems. But I think there's a lot of challenges in integrating the new ways people want to like handle code or compilers are working. Like if you think about Rust, for example, it has like its own incrementality model, and which like doesn't really work very well with how Bazel works, but we would still like to be able to put it in the build system. And I kind of wonder if like eventually we'll all just have like servers which are like keeping the entire state of our program in memory and like incrementally updating it so that we can have really fast compiles. And I don't know how we'll be able to like make our we'll probably still need a build system, but I really want to know how we'll make that all work, because it certainly doesn't fit very well into the Bazel box today.
No, it doesn't fit into the Bazel box, and it doesn't fit into the box of any uncustomized, completely targeted at your world build system. Like that's the idea of keep track of it, because it's the only thing that's ever going to be meaningful to you. And typically that's not how these build systems are developed. They're developed to forget, to throw away, to be able to be moved into a different repo. So yeah, that's a nice killer app. All right, one more question here. Couldn't source files also seen as some kind of build files, but in a different language? Couldn't source files be also seen? I think that question is. So would we just need a transformer as part of a build system?
I mean, yes and no. I mean, there's things which are in build files which are not traditionally put in source files, right? Like compiler options, or like tags, or like other various pieces of meta, or like things that like describe in a large way how you want your app to be assembled. Like, do I want a shared library here, or do I want a like static binary, and stuff like that. So there's definitely still need to have some build metadata, but I don't know how far you really want to go, because there also really is an advantage to like having this independent language for describing how things fit together, and a lot of power in like having a uniform interface to like, I produce something which produces an executable, and like it doesn't matter what language is written in, or anything. Like it's like I build it and then I can execute it. So I don't know how far you can push that, but the main things I'm interested in targeting are like stuff which is redundant with the source code and kind of feels like boilerplate in the build file.
Yeah, in addition, like it seems like, I've been writing build definition files for more than 20 years. The fact that there is a single output from an object file or not an object file, but a source file, and the idea that it doesn't, create its own dependency manifest as a part of some unique traversal of what it actually does, is sort of laughable. We boil things down to nothing but compilations and preprocs in Bazel or in other build tools. But in essence, we should be extracting more information from that, not less, and certainly not the same amount. But thank you very much, Ben. I appreciate that.